All right, so the student sent this message, said they followed along with the video and they got the wrong answer. There's one thing that can cause this that I am almost certain you're going to find out is the reason. Um, you just need to make sure to round your critical value to 3 decimal places as recommended here. So let's go through the steps and see how we do. So we want to estimated population proportion, P. So that means we're going to be using this formula to calculate the margin of error. And actually, it's just this portion of it that is the margin of error, just starting with the critical value. The margin of error is the critical value times the standard error. So that will be our margin of error that they want us to calculate here. Either E or ME, either way, same thing, the margin of error, the yellow part. All right, so we're going to need a critical value z-score for a two-tailed test. We're going to need p hat, q hat, and the division divided by n. So let's find p hat somewhere given in the problem. We have a sample size of 135, so we'll write that down over here. Let's see. Get rid of my little highlighter here. So we're going to do n. I guess we could make this a little smaller here. N is 135. The p hat is given as a percentage, so we'll just write that down as 0.637. We're also going to need q hat, and q hat is always 1 minus p hat. So I'll just go ahead and get that. And then we have our confidence level, which is going to help us find our critical value z-score. So the confidence level, 0.995 as a decimal, alpha equals 1 minus the confidence level, and half of alpha would be the area in one tail under the standard normal bell curve. So that would be half of this, half of 0.0, oops, messed up. There we go, back to here. Now we're going to divide this by 2. And that's the left area for our critical value. Now our critical value when calculating margin error should always be positive. And in this case, it's a z-score, so we're going to use absolute value to make it positive, norm dot inverse because it's a z-score, and the probability is 0.0025, the mean is 0, and the standard deviation is 1. So there's our critical value. Now we have the critical value, so we need that for sure for our formula. And we also need the standard error, which is the square root of p hat times q hat and divided by n. Okay, so this whole portion here under the square root with the square root and everything, that is your standard error. And so these two values multiplied together are going to give you the margin of error. The positive z-score, make sure it's positive, times your standard error, and we should be good to go. Now, the only thing I didn't do here that was recommended was to round our critical value. So I'm going to go ahead and just round this to 3 decimal places as was recommended here, okay, only because the directions tell me to round the critical value to 3 decimal places. So I'm going to go ahead and make this 2.807. And that did change my margin of error a little bit. So that could be why you got it wrong, even though you followed the steps. So let's see. So now as a percentage, here's another thing that could have messed you up. This is decimal form. Percentage form, you move the decimal place to the right twice or multiply this by 100. And so it would be 11.617, okay, as a percentage. And it says to round the final answer to 1 decimal place. So I'm going to round this just to 11.6%. Okay, so I think we're good now. Let's try it out. Yes. Okay, so I hope that answered your question.